Okay, so in this drawing we're looking at the 2010 ordinary level perspective question. So the 3D graphic on the right shows a model of a tent which has a side window. Figure 3b shows the plan and the elevation of the tent. So part A of the question says draw the given plan, which we have already done. And part B says make a perspective drawing of the structure given the following. The spectator point is 70 millimeters from corner A. So first of all, let's find corner A. Okay, so this guy down here is our corner A. The picture plane touches the corner A, so the picture plane will pass through here. And the horizontal line is 30 mil above the ground line. Okay, so first thing we got to do is locate the spectator. So the question told us a spectator was 70 mil down from corner A, and it's straight down in this particular question. So from corner A, I'm going to measure down 70. And that point there is my spectator. Okay, so I'll label him S. So, in order to start perspective, what we need to set up first is our cone of vision. So to do that, we take the two extreme ends of the plan view that we can see, which is this corner here. And this corner on this side. Okay, so we have our cone of vision. Next, we need to establish our line of sight. So in order to get the line of sight, we must bisect the angle that the cone of vision makes. So from S, swing an arc on your compass. Don't change the distance on your compass. Swing where it intersects one side, and swing where it intersects the opposite side from your cone of vision. When the two arcs cross at this point here, from S, we're going to draw a new line, and this is called our line of sight. Now, once we have our line of sight, we can start to find our picture plane. The picture plane will always be at 90 degrees to our line of sight. So I'm going to set up my sliding set square. Hopefully he fits. If he doesn't fit, we'll have to go with the sliding set squares. Yeah, it doesn't look like he's going to fit that direction, and I can't get him that way. So I am going to have to use my slide. So set up one set square along your line of sight, like so. Slide it back. Swap the other set square out. Place it flat against your 45 degree, and through A you are going to draw a line. This line is our picture plane. Okay, and like the question said, it must pass through corner A. So in this case it does, and it is 90 degrees to our line of sight. Make sure it's extended out enough. Okay, so with that established, the next thing we got to find is our vanishing points. So to find the vanishing points, we must follow the lines in our plan, the same from our spectator. So what I mean by that is the angle that they are in the plan will be the same angle from the spectator. So this one here is going to be going parallel from the spectator to where it hits the picture plane. Like so. And the same will be done on this side here. Make sure it's parallel to the plan. Bring him down from S, your spectator. Draw a line out to hit your picture plane, VP2. Okay, so with that discovered, we now need to find our ground line and our horizon line. Best practice would always be to start with your ground line, then your horizon line. Okay, it's easier to gauge your distances if you start with the ground. So you always try and place the ground as close to the bottom as practically possible. So I'll draw my ground line in around here. And the question tells us that the horizon line is only 30 mil above it. So from this line, measure up 30. Don't forget that these lines are parallel to the picture plane. And now I can draw in my horizon. The horizon line and the ground line are both construction lines, so when you're drawn, they will go in nice and light. Horizon line and my ground line. Now I need to get my vanishing points from the picture plane down to the horizon line. So I must come through the picture plane at 90 degrees, which will be at 90 degrees to both these lines. But in this case I need to bring the vanishing points down to where they hit the horizon line. So go 90 degrees through your picture plane down to your horizon line, and the same with VP1. And you can see now that I've found my vanishing points on the horizon line. VP1, VP2. Okay, so corner A touches the picture plane, therefore if I bring that line down parallel to these lines, of course, I can use any measurements from the front of the object on my drawing, and they'll have the same measurement. So I'm going to project him down with my orange marker. Because he touches the picture plane, we don't have to bring him to the spectator first, because he's already on the picture plane. If the point was away from the picture plane, you'd have to first bring him to the spectator. You'll see that when I go to bring additional points down. So I'm going to go back to my original question to get some of the heights that I need for this drawing. Okay, so in the elevation we're told our first height is up 15. So we're going to measure up 15. Which ends up here. And we're going to vanish in back to VP2 and VP1. The same will happen along the ground. Bring them back to both vanishing points. And what I'm going to do next is I'm going to find this front line here where it stops along in my perspective, so I can start to darken in some of my object. So you can see where this point here joins the spectator, where it cuts the picture plane is the point that we project down. Okay, so now that's the front face of the house, and I'm going to darken him in to help me better picture the image or the question as I go along. same. It's going to happen on this side of the house. And I know that this is the back point, so he's already joined to the spectator. So where he hits the picture plane, I can drop him down as well. Okay, so now I'm going to darken in any other lines that I think I can, that I know I can darken in. Just this ground line here. Okay, so the next point that I wish to find will be the height of the roof. It's this point here. I'm going to bring him down. So first of all, I've got to connect him to the spectator. So grab him, bring him down to the spectator. And where he crosses the picture plane is the point that I'm going to project down to my perspective. I'll show your lines are parallel. Where he crosses, there we go. I'm going to bring him down. Now, I need to find out the overall height of the roof so that I can find where that slope is going from, and that is given us in the question. And we are told that it is up 65 millimeters. So again, along this true length line, I'm going to measure up 65. Mark it here, and I'm going to vanish him back to VP1. I know that the top of my roof sits here at this point, so I can now join them back from here and here. So I'm going to do that in dark. That's that side of the house complete. At this point here now, we get vanished back to VP2, giving me the slope of the roof going in the opposite direction. Okay. Now, I need to find this point of the roof, which is given to me at this point of the question here. So again, he must be brought to our spectator and then brought down to our perspective. So grab him, bring him to the spectator. When he crosses the picture plane, we'll drop him down to our question. So we're going parallel. And you can see he's crossing here. And where he cuts this line here is the point in which the roof in which he stops. So I can now also darken that part of the roof in. And I can connect them to the wall. Okay, we are left with the window to draw in now at this stage. Okay, so the window is a wee bit trickier because he's sitting in the middle of the sloped surface. We can't find out where he is by just bringing the points to the spectator. What we need to do is find a reference point on the edge, so we can get a reference point on the edge of our perspective to locate its position. on the sloped surface. So in order to do that, we want to extend one line out to the edge of our plan view. Like so. And we're going to bring this point down to our spectator. And again, when he crosses the picture plane, we bring him down to our perspective. Where he hits that slope. That slope then gets vanished back to our VP. Mine is connected around here, and I want to vanish him back to the VP here. Okay, so that line here means that the bottom of our window sits somewhere along this point. Now, we're not sure where, but we can easily find that out by bringing down the 2 points from the window from our plan down into our perspective. So I'll quickly do that. Again, both points have to go to our spectator and down to our perspective. One. The second fella is coming from here. That's our second one. So you can see we're across that line. That is the bottom of our window. So I'm going to put him in dark. That gives me the starting point to build the rest of the window from. Now, I also need to find out where the window hits along here. So I have to bring these 2 points down also. Again, drop them to your spectator before you bring them down to your perspective. So drop. And we'll drop this fella as well. When they hit the picture plane, I want to bring them down. Keeping it parallel. Put some there. Cuts here. Now, it slopes out. So we have to find where it slopes out. So in order to do that, we need to get a true length line. Okay, so when I was extending this line out, I extended it to the edge, but I also extended it to hit the picture plane. Okay, and the reason I did so was if I have any line that's touching your picture plane can be measured directly from, measurements directly from your elevation can be used on that particular line. So I'm going to bring him down to hit the ground line. I want to measure up 50, which the question tells us is the height, and vanish him back to my VP. With him vanished back, I now know all the information I need to finish my window. Make sure I'm following the right point. Yep. And of course, I have to darken this line here. Okay, so that's your ordinary level 2010 question fully complete.